In this video, we're going to look at calculating pHs of strong acid solutions. So remember that strong acids completely dissociate. The reaction goes to completion. All of the reactants are converted into products. So if I have something like HCl, all of that HCl reacts with the water and it is completely converted into chloride ions and hydronium ions. And so dealing with strong acids is actually pretty simple, because whatever the concentration of, in this case, the HCl was, that is going to be the concentration of the H3O+. Alright, so I've got this example here, and we'll do it on the next slide where we've got a little bit more room. Alright, so I want to know what the hydronium ion concentration and the pH are of a solution made by dissolving 12.5 grams of HCl in 250 milliliters of water. So basically all I need to do is calculate the concentration of HCl, and that will be equal to the concentration of the hydronium ions. So in order to calculate the concentration, I need the moles and the liters. I've got the milliliters, but I need to convert those 12.5 grams into moles. So I'm going to take my 12.5 grams. Well, first, I want to write it out. The molar mass of HCl is 1.01 plus 35.45, so the molar mass is 36.46 grams per mole. So when I take those 12.5 grams of HCl, divide that by the molar mass, so that gives me 0.343 moles of HCl. So then to get its molarity, I'll use M is equal to N over V. So I have 0.343 moles. Divide that by the volume in liters now. So I've got to convert those 250 milliliters into liters. So divide by 1,000, so that'll be 0.250 liters. And so that gives me a concentration of 1.37 molar. Right, but because the HCl is going to completely dissociate, that is the HCl concentration, but that is, at least initially, but since it completely dissociates, that is the H3O plus concentration. Okay, and then we also need the pH, so I just need to take the negative log of the H3O plus concentration, and I get negative 0.137 as the pH. Okay, and I picked this problem specifically because sometimes I find that this surprises students. The pHs can in fact be negative. If the concentration of the strong acid is greater than 1 molar, then the pH is actually going to come out to be negative. Okay, I just wanted to do one more example dealing with a polyprotic acid. I just wanted to point out, based on our discussion before, it doesn't matter that there are 2 protons in sulfuric acid. It's only the first one that we're really worried about as far as contributing to the H3O plus concentration. And so if I wanted to know the pH of 0.00782 molar solution of sulfuric acid, since I already have the concentration of sulfuric acid, that will be the concentration of hydronium ions. I don't have to worry about the second proton, and so the pH will just be and I get 2.11 for the pH of this solution. Okay, in the next video we'll look at calculating the pH of weak acids.